All right, everybody, welcome. Welcome to class. Going to get started here. What I will say is I'm going to be showing you stuff that isn't going to show up on the Zoom. So if you want to also hop into the YouTube stream, you might want to do that so you can watch the visuals as I'm showing you some math stuff today. What some people like to do, you kind of have the vocals on in Zoom, and then you can bring up the YouTube stream and just mute it. However you want to do it, right? You don't want to have both going because you'll hear like an echo and it's kind of annoying. So you could just mute one or the other. Some people just like to hang out in the YouTube stream, whatever works for you, but you probably can't have the audio on both going. So you can just mute one or the other, or however you like to do it. It's fine. I would like to say good work so far. Most of you are progressing nicely through the course. So I'm looking and it looks like most of the students in this course are making what I would call productive progress, right? You're sort of on track towards stuff. One thing I want to point out, because it can kind of worry students a little bit, is your homework grade is going to fluctuate. So some of you may have noticed, like some of you had hundreds on the first 3 assignments. Well, yesterday I went through and I added, I forget if it was 2 or 3 more assignments. And then your grade drops on the homework. So don't panic about that. The reason that grade is dropping is because it considers you to have zeros on the new assignments that I added. So you haven't done anything wrong. It's just that now there's more assignments in front of you that you haven't completed yet. Once you get hundreds on those, your grade's going to come back up. Okay, so really the key for what you want, it looks like a lot of you are doing exactly this, is you just want it to say 100% inside each of those boxes that represent your homework grade. I forget what the grade looks like on your end, but on my end, it just, for each assignment, it shows, 100%, 100%, 100%. If you keep doing that, you're good, and by the time you get to the end of the semester, if you have 100% all the way across, guess what? Your homework average is going to be 100%. So that's obviously very good in a class where, what is it? Homework's worth, I think, 50% in this class. I'd have to double check the syllabus, but I think that in this one it's 50%. So that's good then, obviously. So just keep doing that. Don't worry about the ups and downs of the grade as I add new assignments, because it's grading you on assignments that you haven't done yet, right? So don't panic on that. Just realize that at some point by the end of the semester, you have to have gotten 100% or, high grades. Some of you might end up with a 75% or a 90% on a homework here and there, but getting those 100% is really a good way to make sure you're learning the material for the exams, and then also to have that really strong homework score. Okay, so what I would like to do before we get started is open things and just ask, does anybody need, does anyone have a question? Have any questions arisen? I know I've gotten some emails, but I haven't seen any emails that make me think there's particular problems we need to cover in class. If say I get like, 2, 3, 4 students emailing me about the same homework problem, that's an indication to me that I should go over that one in class. So that's helpful, because otherwise I'm just sort of making up what I think needs to be covered. Because as I mentioned, I can't cover everything, so I'm kind of covering the stuff that I think is most fundamental. But if I'm seeing students ask me the same question, that indicates to me, oh, I should spend some time in class covering that particular problem and going over it. Okay, so feel free to contact me with questions, office hours, all that kind of stuff. Yesterday was my on-campus office hours, and I did have 2 students show up, which was good. That's good. Students are showing up to those office hours. And then I just finished, right before this class, was one of my online office hours for the week. I do have another online office hour on Thursday. So, feel free to email me, contact me, message me, whatever. I think I mentioned this before, but there is on-campus tutoring right now. So on the Ventura College campus, I believe what they told us was that the tutoring center is open for in-person visits now. Something occurred to me. I got to make a note to myself here. Something I didn't have time to do right before class. What was I saying? Oh, right, the tutoring. So feel free to go to those. They do, I believe, still have online tutoring. So if you want to use the Zoom meetings for tutoring, I believe they are still doing those. Although I think at least the current plan. We'll see what actually unfolds in the next 6 months as far as COVID. But I think the process is that by spring, they hope to be mainly back to on-ground tutoring, since they want most of the classes to be on ground in the spring. So just kind of be ready for that. But I believe right now you can still get the Zoom tutoring. If you just Google, in fact, I can show you. If we go here, and if I just search for tutoring or tutor, I forget if it's tutor or tutoring. Probably either one works. We get online tutoring. Where's the tutoring center? Tutor center. Math tutoring center. Is that the old one? Yep, that's the old one. That doesn't even exist anymore. That shouldn't even really be up here. You've got the tutoring center, right? And in here, they've got their hours for which the tutoring center is running, right? So that's pretty good. 8 to 8, Monday through Thursday, 9 to 1 on Saturday, and even some Sunday hours. So depending on whatever times you have available, you should be able to get in for some of those, and you can get help with that. And then I think they still have the online tutoring. So if you go over here to the right, see it says online tutoring, you can click that. And then they have appointment request form. So I think they've and then there's virtual office hours. So you can, if you click this, I believe it'll just open a Zoom meeting and you'll go right into it. Versus here, you can set up an actual appointment. So you can say, oh, I'd like to meet at this time with a tutor. You can set all that up. Of course, I have office hours, but my office hours are much more limited than the tutoring center. But you definitely want to make sure you get that help. If you reach a point where you're having difficulty in the course, make sure you get some help with it, okay? Let's see, a couple of questions to address here. Let's see, what do we got? Yep, okay, great. That's a good one. And then, so then there was a question, there were assignments before I enrolled at the beginning of class. Should we do those assignments? Yeah, you want to do all those assignments as much as you can. Even if you have to do them late, you still get 50% credit for doing the homework assignments late. So obviously, if you're going to spend the time doing a homework assignment, you'd rather get 100% credit than 50% credit. But even that 50% credit is going to help you, right? Because zeros are really bad, right? If you think about the average, if you're averaging things out, a zero pulls everything way, way down. You know, let's say you take, you have 2 tests. Well, let's see. Let's make this a little easier. Say we have 3 tests where you get an 80% and then you miss 1 test. Not for this class because we don't have that many tests. But let's just say you have a class where you have 4 tests. 3 of them you get an 80% and then 1 of them you get a 0. You're now looking at what? You're now looking at like a 60% average. So even though you consistently were getting 80%, that 0 pulls everything way, way down. So you don't want zeros in that homework. What you really want is hundreds. But if you have to, take the penalty and still get that stuff done at a later date. It's just going to help you down the road. Usually what happens is people's test scores are a little lower than their homework scores. In other words, your homework score pulls you up, pulls your grade up a bit, right? That's for almost everyone because you can work on the homework till you get it right. So people who get 80s, hopefully their homework is like in the 90s because it's going to pull that 80% up and put you at least in a solid B and not where you're going to dip down into a C range or something like that. So any points you can get from the homework, those are no-brainers. It takes effort to do the homework, but it's sort of guaranteed points. Whereas when you go into exams, there's no guaranteed points. You know, if you mess up, you're going to miss out on points. So you want that homework score to pull you up. You want it to pull you up in things. Okay, are there other questions? Anything else that people are, it kind of seems like people are progressing. So to me, that means that you've all kind of figured out what you're responsible for and what you're supposed to do. So that's good. I'm going to go over a little bit of stuff from this chapter 1 here, and then pretty soon, probably later today, we'll move into chapter 2. And there's a couple new assignments up to cover this. Darn it, there's some kind of bug flying around in the room here. We'll get into solving equations, and so you've got a couple of assignments here. right, that you'll cover here, and then we'll just keep progressing. You can see chapter 3 on my screen, but it shouldn't. I don't think it's going to show up on your screen because I haven't released it yet. This little, if you look over to the side, the fact that this is not a green check means I have not released chapter 3 to you yet. I'm not releasing the entire course yet. I'm kind of releasing it as we go, but you'll be working through these modules. I don't want to overwhelm everyone at first, but you've got these first 2 chapters that you can be working on and progressing, and the chapter 2 homework is now up. So any students who wanted to dive into that and start making progress can do that. But I want to go over this simplifying expressions a little bit. And hopefully it's all working. Delta Math went weird. When I was setting things up, everything worked properly. And then right before class, the Delta Math website was sort of giving me a hiccup. I think maybe it just had logged me out or something. I'm not sure. Like I needed to refresh. I'm not sure what it was doing, but I think it's up and working again. So if there are no questions, Anderson, there shouldn't have been anything due May 1st. They were due May 1st. Let me take a look at that. Make sure I'm not putting something on screen that shouldn't be there. Let's see. Let's go to... William, do you know like which assignment are you looking at? I'm just trying to figure this out because that doesn't sound right. I must have a setting wrong somewhere, but there shouldn't have been anything due May 1st. Let me see. So if I'm looking at the... now it's doing it again. Okay, just signed in. Go to here. Sample student page. Math 1. I actually want to go to teacher account, go to view assignments. All these assignments, there should only be 5 assignments available to you. Oh, and I see a couple of you have even started the chapter 2 stuff. Good for you. That's good. Factoring help. Let's see. There shouldn't be any factoring homework available to you. This is Math 1 beginning algebra, right? We're in a... Right, am I in the right? It's logging me out of everything here. Yeah, Tuesday, 10 o'clock Math 1. In Canvas. Oh, in Canvas. I see. Okay, in Canvas. Let's check that out. Do I have something left over from before? Oh, the factoring help May 1st. Yep. Okay. You're right. So that is from a previous time. Let's just go through. That's not been released yet. Yeah, you can't even do that yet because it shouldn't be released yet. So let's see. I'll just change that to sometime in the future. Thanks. I hadn't that one slipped through the cracks. So let me fix that. I'll just change the date here so that it's not concerning to anyone. Let's see. Let's make this available starting August 16th, and we'll make it due. We probably won't get to that till like October or something. So ignore the date for now. I'll just set it in the future so no one's worried about it. I'll have to change those dates when we get there. And then, yeah, so anything for future chapters, you don't have to worry about that yet. Let's see if there's any other weird dates. I don't know how that one slipped through where it was had an old date. I must have just missed it when I was doing that. So thanks for pointing that out. You don't have to worry about that yet. So for now, make sure you're just following the 2 modules that are up here. And then make sure you're doing the just chapters 1 and 2 are basically what you should be focusing on. Okay, so with that said, if there's no other questions, I'm going to jump into just showing you some actual problems that we can work on. So let's take a look. Here's a Delta Math problem. So this is literally pulled from the Delta Math homework. Do be aware these problems are randomized. So if two of you go in and start the homework, you're not going to get the same exact problem. These numbers that appear in here are randomized so that they'll be different for each of you, but the form of the problem will be the same, right? The form of the problem will be exactly the same, so that you should, if you're able to do one of these, you should be able to help your friend. Even though your friend has different numbers, you can help them out and check that out. And don't forget, a lot of people forget about this watch help video, right? That's really helpful. Those videos are in there, and I can see that most students skip the videos, and skipping the videos is totally fine if you know how to do the material, right? You don't have to sit there and watch a video if you know what you're doing and you're getting all the problems right. But if you're getting a problem wrong, if you're having trouble with a homework problem, really the first thing you should do is come up here and click watch help video. So if I click that, right, a video pops up and it's going to show me, notice the problem that they're doing here. I've got it on mute so that we don't have two people talking at once. But you would did it unmute? Let's see, unmute. Notice how, let's have it play. Notice how the problem here is different than the problem you're doing, but it's very similar in that basically what you're getting is a distributive property problem. So you're using the distributive property, you're going to learn what they're showing you in the video, and then you're going to apply it to your problem that you're working on. So that's like step 1 and 2 for me. I would come in, I would look at the problem and go, do I know how to do this? And if I do know how to do it, I would just complete the problem. But if I don't know how to do it, or if I think I know how to do it, but I get the problem wrong, that's an indication I don't actually know how to do it, right? Unless sometimes a person just makes a silly mistake. I've talked about that in here before, and I'm sure I'll talk about it again. Mistakes happen when you do mathematics. It happens at all levels of mathematics. People make like silly mistakes, okay? Like I'll see this on tests where someone will be doing a problem and they'll write that 5 times 4 is 9. Well, of course, the person doesn't think that 5 times 4 is 9. They were just nervous because they were taking a test and they made a silly little error. So something like that is not going to get you, like if I'm grading a test by hand, I'm not going to take off a ton of points for that because I go, I know this person knows that 5 times 4 is 20 and not 9. They just made a mistake because they were nervous on the test. That happens. But if you think you know how to do, like I'll hear that from people and go, oh, I know how to do this problem. I learned it 2 years ago in math. And then they keep getting them wrong. Well, just because you've seen the problem before, or even that you were able to do it before, doesn't mean you know it anymore, right? People forget their mathematics. It's like a muscle. It atrophies if you don't use it. So what you want to do is, take the clues from the problem and go, I keep missing these. Maybe I don't know them as well as I think I do. And then you watch the video. And the video is going to be very directed. It's very close to the problem that you're working on, and it's going to help you work through those problems, okay? So I would do that. Now, I'd want it to go away, so I'm just going to hit hide video. So you can do it either way. You can have it, notice that you can have it here and still, it's not going to let me go down. You can still kind of do the well, I can't show it. I don't have room to pull this up, but you can still do the problem while the video is written here, or you can just hide the video and then you get the problem back. Okay. I know a lot of times, we'll be a few weeks in, like sometimes a few months into the semester, and then someone will go, wait, there's videos in the homework? And they're kind of surprised that there's videos there. Yeah, you got to be observant. You got to look around, look at everything that's available on this screen, because most of it there, the whole reason that it's there is to help you move forward and be successful in that problem, right? So part of what we're doing today is I'm showing you how to use this distributive property and simplifying, but also I'm showing you directly how to use this homework page, okay, so that you can be successful when you're at home and go, oh, that's right, there's that watch help video. I don't love the font that they use. This is almost like it's not exactly Comic Sans, but it's not exactly like a professional font. So it looks kind of silly, and it's kind of interesting how some of us are trained to ignore certain parts of a web page or certain details, like usually the really tiny writing at the bottom of a page. How often do you read that? Never. If it's off to the side, our brain ignores it because that's usually where the ads are, right? But in this homework, it's worth it to you to make sure that you're looking at all the pieces that can help you. So what do we have up here? We have a show example. So if I click that, look, it actually shows me a similar problem, different problem, but it shows me what the steps I have to do. So in this case, you might look at this and go, oh, that's right. Now I remember. Now I remember what I'm supposed to do here. And then you can go back and work on, there's some examples there. You can look at them and go, okay, now I remember what I'm supposed to do here. And you go through and work on that. There's also see solution, which I don't want to click yet. It's going to actually show me the solution when I do the problem. At least it should. And that's helpful. And then notice this information up here. Remember, in order to master this skill, I have to get a score of 5 on here. So the way it works is when I make a homework assignment, I go in and I pick a number of different topics that I want to occur in the homework assignment. And in order, I can change some of these values. The default is 5. It makes you do 5 problems of a certain type. If you get them right, it moves you on. So each time you get a problem right, it gives you like, the score is different than your points, okay? The points is like the 100% you get for the problem. The score is keeping track of how well you're doing on that topic. You need to get, like for this one, you need to get a score of 5 in order to move on to the next topic, okay? So it's saying, oh, you have 0 out of 5 here, and for the penalty is 1 off. That means that if you get one wrong, you lose 1 score point. So basically, if you get one wrong, you have to get one right to get back to that same level. And then you have to work your way up to 5 points, and it moves you on to the next topic at that point. So that's how that works. So these might seem confusing here. What do you mean score? What does that mean? Is that my points for the assignment? No, your points for the assignment are that percentage you get at the end when it says 100% when you've completed it all. These are about moving on to the next topic because most homework assignments have a few topics. Okay, with that said, let's do this problem right here. I'm going to walk through this, and some of you already completed this. Great job. Keep up the good work. Some of you have not, so let's take a look at how that works. So it's going to be so we've got -7 times some stuff, and then minus 8h, and we've got -7h minus h plus 4. Okay, -7h minus h plus 4. Did I get that right? Let's see if that looks right. Yeah, I believe that's right. Okay, so this is here, and then let's read the directions, okay? Because a lot of times students, I just talked about stuff that people sort of don't do when they're doing these problems and the parts that they skip ahead. One of the things that a lot of students do is they skip the directions. They just look at the problem and go, well, I've seen this before. You should read the directions, right? How are you supposed to know what to do in a problem if you're not reading the directions? And I'll see that on tests where a student doesn't read the directions and they do the complete wrong thing. Like they do, they might do one thing with the problem when the directions were actually to do a different thing. So make sure it's, it's worth, in this case, like 1 second to make sure that you're reading the directions and doing the right thing. Rewrite in simplest terms. That took about a second to read it, but now we know we're going to do the right thing. We're not going to, especially later in the course when you have more tools, someone might look at a problem like this where I say simplify and they go, oh, am I supposed to factor that? And then they go through and factor it, and it's like, that's not what you were supposed to do here. So even though you did the thing you did correctly, you did the wrong thing, right? And so you don't get credit for that. It would be a wrong answer. Okay, so we know we are supposed to simplify this as much as possible. So what does that mean? Well, we can have these mathematical expressions that are in all sorts of different forms, right? We can put them in more complicated forms, simpler forms, all sorts of stuff. There's always operations, and we'll learn about some of this maybe later today, otherwise next time, about things we can do to make equations and expressions look different, but they still represent the same thing. Okay, like x plus x can also be represented with 2x. Those mean the same thing. X plus x and 2x mean the same thing. So, well, what form should it be in then? Well, if you think about it, it makes sense. We want things in the simplest form, right? I think a lot of times people they hear this simplify, and they go, oh, why is my teacher making me simplify? Well, it makes sense. If you're going to be dealing with mathematics, wouldn't you want to be dealing with the simplest form that you can, right? Why would you want to deal with an overly complicated form of something? When you deal with stuff that's more complicated than it needs to be, what you're going to do is make more mistakes. And mathematics is already pretty error prone. Anytime someone deals with mathematics, you're going to make mistakes here and there. Hopefully you make very few, but mistakes are going to pop up. The more complicated and disorganized your work is, the more mistakes you're going to make, right? And a lot of people don't realize this. Part of the battle, maybe a fourth of the battle of doing well in math, is just having neat, organized work, right? If your work is in an organized manner, you're much less likely to do the wrong thing because you have it laid out in front of you exactly what you're supposed to do, and it's simple to see what the next step is. So we always like things in simplest forms because why not? Why would you want them in a complicated form? Right? If I'm going to give you two problems and I say I can give you the simple one or the complex one, which one are you going to choose? You're probably going to choose the simple one, right? So let's see what we would do here. Well, what you want to keep in mind when we simplify things is a term that you've probably heard before, but you may have forgotten, which is to combine like terms. Let me write this out here. Combine like terms. Oops, that's not terms. Terms, combine like terms. So what is, oops, still got it wrong. Combine like terms. There we go. That means that you can take things that are of the same type and you can combine those together using addition and subtraction, but you can't take things that aren't the same type and you cannot combine those together, okay? And this can get a little confusing for people because we can combine whatever we want for multiplication, but we cannot combine whatever we want for addition or subtraction. Now, why would that be? Well, if you think about it, when we are adding and subtracting things from each other, all we're really doing is counting those things, right? So let me kind of take a sidestep down to another page. We'll come back to this problem in just a moment, but I want to talk a little bit more about combining like terms so that we can really, all right, I don't want it to be something that you memorize. I want it to be something that you understand. Because if you understand it, it's a concept that'll stay with you. If you've memorized it, you'll forget it in, a couple of months. So combine like terms. Well, let's say I wanted to, like, what do I mean when I say that adding is really a form of counting? Well, let's say I go out and I've got, an apple tree in the backyard. And I've got, okay, well, I went over to the tree and I collected 5 apples. Okay, so I've got 5 apples there. Then I'd say, oh, you know what? I think I see some apples over there that fell on the other side of the tree. I'm going to go pick those apples up. And I picked 3 more apples. Oh, where is it? I was not typing in the right place. Plus 3 apples. So now I've got 3 more apples. I started with 5 apples, and now I found 3 more apples. So what do I have? Well, I've got 5 apples in my left hand, 3 apples in my right hand. How many apples do I have total? 8 apples. Do you see how we did an addition problem there, right? It's written in words, but really the word plus obviously becomes a plus sign. The word is becomes the equal sign. This is 5 apples plus 3 apples equals 8 apples, right? What did I do? I counted how many apples I had. That's all we accomplished there, was counting the number of apples that we had. Okay. Do you notice how the oh yeah, that's right. The word apples looked weird for a second. Notice how the unit didn't change? When you multiply things, sometimes the unit is going to change. When you add or subtract, your units shouldn't be changing because all I'm doing is counting, right? If I have 5 apples on my left hand, 3 apples on my right hand, I end up with 8 apples. Students sometimes can get confused here, and they'll change the unit, which is like, we'll see in a moment, like the variable. You don't end up with, like, you have 5 apples plus 3 apples. It doesn't become 8 apples squared or something like that. It's still that same object. It's still just apples. So let's, darn it, why does it? Okay, so now let's put this in terms of variables. What if I have 5x's? What if I had 5x's in my left hand, and then I had 3x's in my right hand? How many x's do I have? Well, if I have 5x's and I come across 3 more x's, I have a total of 8 x's. Right? It's literally just like we're using the variable instead of the object of an apple. Oh, that's what I did. I put the code in the chat on accident. Somehow I'd clicked over there. So just ignore that last comment I put in the chat. That was supposed to be over here in the code. So just like 5 apples plus 3 apples is 8 apples, 5x's plus 3x's is 8x's, right? This is a mistake I see all the time where people will do this and go, well, yeah, I've got 5x's and 3x's. Doesn't that become 8x squared because of the 2x's? No, it's just like the apples. Apples doesn't become apples squared or some kind of new thing. It's still that same unit that it was before. So 5x's plus 3x's is 8x's. And we would write it, there we go. We write it like that, where it's just the 8x again. I'll show up on the stream in just a second. So 8x's. So other times too, someone will go, yeah, but I have 5x here and 3x here, but then there's an x, so isn't that 2 more x's? No, the 5 is already counting how many x's you have. So you have a total of the 8 x's, okay? Likewise, it makes sense that we can only combine things that are what we call like terms. What is like terms? What am I talking about when I keep saying like terms? The simple way of thinking about like terms is that they have the same variable type. Okay, the same type of variable makes things alike, right? So in other words, what if I had a problem where what if I had 5 apples? So I go and there was 5 apples sitting below my apple tree, and I collect those apples. And then I have a lemon tree, and I went and I got 3 lemons from the lemon tree. Okay. Well, let's say, like, is there a way that I can combine 5 apples plus 3 lemons? Does that make sense? What would I have? I mean, I guess you could say they're both fruit or something like that, but that's not really what we're trying to get at here. When I try to combine apples and lemons, all I really have is 5 apples and 3 lemons. There's no real way to combine those together in a way that, you know, would be a little bit sort of cheating to say, well, yeah, let's call them fruit. Because then we're not talking about apples and lemons anymore, are we? We're talking about some new type of thing, which is probably not relevant. So when I add together 5 apples plus 3 lemons, I just have 5 apples and 3 lemons. There's nothing to do. There's nothing to combine because they are not like terms. So, you know, there's no simplification there. Okay, so how would this look algebraically? Well, remember how a minute ago we turned our apples into x's? So what if I have 5 x's this time? But now x's are representing apples. So we need another object to represent lemons. Why don't we use y? So 5x plus 3y equals, well, what would happen when I go to combine those together? Well, just like with the apples and lemons that can't be combined, our x's and y's can't be combined because they're different things, right? It's like saying, well, I have, I have 5 basketballs and 3 trees. How am I going to combine those together into something? It doesn't make sense to combine those together. They're different things. So it's the same thing here. If we have different variable types, this variable type is an x, this variable type is a y, I can't combine those together. So 5x plus 3y is just 5x plus 3y. That's as simple as that thing gets. It does not simplify down to anything easier. So if your variables are exactly the same, you can combine them through addition. If the variables are different, we cannot combine them. Okay? And one thing that's going to start to come up later in the class, what if we had this? What if I had, similarly, what if I had 5x squareds and then I had 3x's? Right? There's always a couple students that get confused by this, and rightfully so, right? It's a subtlety that it's reasonable to get confused by this. Could I combine 5x squared plus 3x Do those have the exact same variable type? As students will say, well, they're both x's. They both have the variable x in them, which is true, but one is an x squared and one is an x. So that's a big difference. Like if you're thinking about in terms of measurement, a one-dimensional measurement is very different than a two-dimensional measurement. So let's say that x is a measurement in feet. So it could be the length of a wall. So just pick a wall in the room that you're in, assuming you're indoors. Pick a wall and just think to yourself, okay, if x is feet, then that wall might be, what, 12 feet long, or however long the wall is that you're looking at. That's a linear one-dimensional distance. How long is that wall? X squared is a two-dimensional measurement. That would be like the area of the carpet on the floor, or whatever kind of flooring you have in the room that you're in. That's a two-dimensional measurement. Would it ever make sense to add those together? Would it make sense that I should take the length of the wall in my room and add that to the area of the carpet? No, I cannot think of a possible way that you would do that and get something meaningful, because a linear distance and a two-dimensional measurement are completely different objects. It doesn't make sense to add those together. So these, even though they both have the variable x, are still different variable types, because this is a two-dimensional x and this is a one-dimensional x. Doesn't make sense to add those together. Okay, so just keep that in mind. So that kind of brings together what we mean when we talk about like terms. So let's go back to our original problem. I've got, okay, I can see things in here now. I see, so I see a variable. There's some terms that have an h in them. Okay, so I have three terms that have the variable h. Those are like terms. Okay, also I see some numbers that are not like terms. I've got a 4 here. I've got a -7 here. Okay, so those are some other types of terms. All right, so now at least we know what we're looking at. I'm looking at two types of terms here. Some things have h's as their variable, and some things don't have any variable at all. So now what do we have with this parentheses here? What is that all about? Well, this is what we call the distributive property. So let me take another side step, and let's take a look at the distributive property. The distributive property basically says that if we have a times b plus c, this gives us ab plus ac. Okay, basically you're distributing that a in. This gives us a choice. It says that we can either add b plus c together and then multiply by a, or I can multiply a times b and add that to a times c. Now, why is it such a big deal that we have this ability to do this? Well, what if b plus c, what if those are not like terms? Then we can't just combine them together. We would have to use this right side, right? What's on the right? So we would be forced to use that distributive property. All right, so let's do that. That's the other thing we have. So we have two things to look for here. Combining like terms, but then also the distributive property. In this case, we have three things inside the parentheses. So this -7 is just going to get distributed to all three of those terms. So let's do that. Let's go to our problem here and say, okay, I'm going to distribute that -7 in. So -7 times -7h, a negative times a negative gives me a positive. So that's going to be 49h. 49h for the first term. Okay. Now I'm going to continue to the next one. So -7 times -h is again a negative times a negative. So that's going to give me a positive 7h. So I go plus 7h. Okay, that's the second one. And now I've got -7 times positive 4. Okay, well, a negative times a positive is a negative, so we know we're going to have a negative in there. 7 times 4 is 28. So 49h plus 7h minus 28. And then that -8h is on the outside of the distributive property, so we just are going to leave that as it is. -8h. So now we can look at starting to combine things. We got rid of that parentheses. It's going to be easier to deal with now. Now, some of you may be thinking, why didn't he combine the negative 7h and the negative h right here? You could have done that. If that's a thing that you wanted to do in simplifying this problem, that would work too. So sometimes in these problems, oftentimes, you have a choice about when to do a specific step. If you had wanted to do that step earlier, you could do that. We could have combined those two terms right there. That's fine. I chose to do it differently because I'm trying to show you this distributive property, so we end up with this. But now we're just going to take it step by step and go, okay, well, now what's my next step? Well, what I could do is combine the 49h plus 7h. So if I have 49 h's and I get 7 more h's, I now have 56 h's minus 28 minus 8h. You might go, why didn't he just combine all the h's? Well, when you're first learning a topic, you should write lots of lines, right? I know it's counterintuitive. People want to move fast. It's that old adage, go slow to go fast. If you go slower and don't make mistakes, that is much faster than trying to go fast, making mistakes, and then fixing your mistakes. So I'm just taking it slow, one, so that everyone can follow what I'm doing, but also because less likely for mistakes to occur. So now I'm looking at this. Okay, I have 3 terms. I only have one constant, right? A constant is a term with no variable in it. So it doesn't have any like terms to combine with, but notice I still have 2 h terms, 2 variables with an h in it, and I want to go through and combine those. Well, if I have 56 h's and someone takes 8 h's away, then that should give me, what, 48 h's? So that leaves me with 48h minus 28. Okay, if I didn't mess anything up, that should be my fully simplified version. I can't combine these two terms because they're not like terms. This one has an h variable. This one has no variable at all. So let's go put that into our answer. 48h minus 28. So I go 48h minus 28. And I'm going to and notice that there's some stuff over here. I forget. One's a keyboard. You can't see it, but a keyboard just popped up at the bottom of my screen when I clicked this. And that allows you to do things like square roots, exponents, stuff like that. So you can play around with that. I forget what the plus and minus do. So I submit my answer, and it says, are you sure you want to submit this answer? It's in your best interest to double check your answers before you submit them, because remember, if you get it wrong, you now have to do a problem to get that point back. So it's almost like you have to do 2 problems now to progress. If I get this right, this one problem, I'll progress. If I get this wrong, I have to do 2 problems to progress. That's twice as much work. In real life, you should check your work anyways. A lot of times people think checking their work is optional. In real life, you always have to check your work because there's no back of the book to like check your answer, right? Like we don't, since it's online, we don't do that much anymore. But like even the online homework sometimes will tell you got it right or wrong. But here you get penalized. So you really want to know, did I do that right before I put it in there? But I say, yes, I'm willing to submit this. I hit yes, and I get my green check. Great. I got it right. But notice that it also works the problem out for me. So that if I got the problem right, I can just see, oh, look, they actually did it a different way, and we still got the same answer. See, they did that thing that I mentioned. You could combine the negative 7h and the negative h right out of the gate. That's what they chose to do. Both ways are perfectly legitimate. The way I did it is totally legitimate. The way they're showing here is totally legitimate. And sometimes students will say, well, what's the right answer? They're both right, okay, because they both get you to the right place. Okay, and they're giving you the directions over here about how to, the steps that they took. And so hear those phrases, combine like terms, right? Combining, you're distributing, distributive property, identify like terms. They're doing the same thing that we just did, okay? So that's how that goes. And then, look, I got my record now. It says I got 1 correct of the 5 that I need. My score is a 1. That record keeps track of the best that you did. That's the highest score that you've had. But if your highest score is at a 4, your current score or your record's at a 4 out of 5, your actual score could have dropped down to like say a 2 if you got a couple wrong. So really this is the one that you'll be looking for is your score. You want that score to get up to this 5 value right here, right? If I get one wrong, I get 1 off, right? So then you'll say, great, this says I'm 5% complete on the assignment. Now I'm gonna move ahead, right? So then I click next problem, and I go to the next one. And then I've got a few more of these that I got to go through and do in order to complete this part of the assignment. Once that score hits 5, it's going to move me to the next topic, and you're going to see a different type of problem. Now, like I said, it's 5 here, but in some assignments it'll only be 3 because sometimes I put so many topics in a homework. Like this happened yesterday, I forget which class, but I made an assignment and it said it was going to take students 3.5 hours to do that assignment because it keeps track of how often it takes most students to complete a problem. So it actually tells me the expected duration that a homework problem should take students to complete. I had one yesterday when I was creating assignments. I don't remember if it was this class or my Math 3 class, but it said it was going to take 3.5 hours to complete. So what I did was I went through, and instead of needing 5s for each one, you need like 1s and 2s. And then it brought it down to where the assignment was a little over an hour long, and then it's a little bit reasonable. So that number will change for different topics. But for this one, it makes sense. Yeah, if you can do 5 of these, then you probably understand what's going on, right? You probably get it. And then you can also do like C solution. It says, are you sure you want to show the solution? Pressing C solution will have the same effect as answering the question incorrectly. So basically, it's like getting the problem wrong. So you probably don't want to see the solution. You might as well try to get it right. Like you'll lose a point, basically. Try to get it right, and then if you're wrong, you can look at the solution. Excuse me, but you might as well try to get it correct, right? So hopefully that gives you some indication about how to use this program. Notice there is let me see if I can move it this way. Nope, still a little too high. Down. Notice there's a calculator button here. So graphing calculator, statistics calculator. You won't need the statistics calculator. You probably won't even really need the graphing calculator, but there will be times when you can come in here and you can use this graphing calculator. And then you've got the calculator down here at the bottom. When you press this, let's see if I move this up. You might be able to see it. If I move it up, see at the bottom of the screen, there's this little calculator for you to use. And over here is where you can use the X and Y. You can type X and Y, and you can type the exponents and square roots and stuff like that. But the square root's a little tricky because there's no square root button on the keyboard, that is. There is a square root button here on the keyboard, and you can use the equal sign. So any of these buttons that occur on the keyboard, you could use the keyboard as well, but it's up to you. Okay, so that kind of runs us out of time. So hopefully now and most of you, it looked like, are already pretty comfortable with the homework because I see a lot of people with 100%, but I wanted to point out those other features so that you would make sure you're using them, right? If you're stuck, watch the video. If you're blasting through problems and you don't need help, well, then just keep going and getting the problems right. But as soon as you get stuck and you get a couple wrong, watch the video, right? Sometimes students are convinced they know how to do it, even though they're getting the problems wrong consistently. Yeah, if you get one wrong, you might know how to do it and you just made a silly mistake. But if you're consistently getting the problems wrong, it means you probably don't understand how to do that problem. Watch the video. Just watch the video and go, oh, that's what I'm doing wrong. I'm messing up my negatives or something. Just, go slow to go fast. Watch the video. And that might actually mean that you get through this portion of the homework faster because you took the time to watch the video. Okay, so what I will do here is I will turn off the YouTube stream now, and anyone who wants to hop into Zoom and ask me any kind of questions about the course, please do so, and I'll stick around and I'll answer your questions for you. Okay, so thanks everybody. Keep up the good work. Those of you who have gotten a little behind, you're not that behind yet. Just get yourself caught up, and then you won't have that stress of trying to do a big catch up. You just stay consistent and current. And that's going to help you overall. Okay, thanks everybody. We'll see you later.